Hello and welcome back everyone to the next episode on SAP DataSphere training with me Anubhav. In the last episode we talked about the concept of working with our layers of SAP DataSphere. First we saw how to set up your SAP DataSphere tenant for free. Along with that you learned how can we set up the SAP Analytics Cloud tenant as well for the guided experience. Followed by that you saw the system walkthrough, the different options which are available in the burger icon on the left side. Along with that, we saw the concept of spaces. Space provides a very good isolation. It allows you to control the usage quota, control who can develop in which space, along with the different settings at a space level and connections. We also add the members to the space to allow the developers and consultants to be part of a space so that they don't disturb each other's work, and also the data sharing. We learned about space management settings. Followed by that, I showed you behind the scene what is going on. We saw what is HANA Cloud and what is HDI and a database user. We talked about the important resources for study material and books which are available and provided by SAP for free for your further learning. In case you want to read the books, always refer to the latest and greatest material provided by SAP. Then we discuss the different system roles, the system owner, who is the owner of the system, the database warehouse administrator, space administrator, integrator, modeler, viewer, and consumer. We also talk about catalog admin and catalog user roles. We saw as a datasphere modeler what are all the different layers you will be typically working with. So we have two predominantly used layers, the so-called data builder layer and the business builder layer. The data builder layer is predominantly used by a IT colleague like a developer or a modeler, a technical consultant like you and me who have very good understanding of technicalities. Here we focus more on combining and preparing our data, building different data artifacts to be used by the business consultant in the business layer. Whereas in the business layer, it is more about focusing on semantics and the business use cases. The idea is to give a tangible stability over a time to the data layer and then have a business layer on top of it for particular use cases to build KPIs, aggregations, consumptions using different tool, combine, refine, enrich your data builder artifacts together to achieve a particular use case and add semantic information which is tightly focused for the consumption of these objects in the analytic cloud. We talked about all these layers. You can see in the data builder layer we have different options like table, upload, graphical view, SQL view, entity relation, data flow. And in the the business layer we have dimension, analytic dataset, fact model, and consumption model. We started with the data builder introduction. We saw a data builder consists of different variety of artifacts to give the base layer ready to allow your businesses to bring in the data in datasphere and build this basic skeleton or the foundation for your data. We have tables to create a two-dimension structure, graphical views, SQL views, data flows, intelligent lookups, and task chains. Now, in today's class, we will start using data layer to build our data foundation. But before we do that, let's talk about a very important topic called dimension or measure. I have some of the students who have joined this course without any prior experience of BW. You have no clue what is BW. Still, you have joined this training because of my promise to you. And of course, even without having that knowledge, you will be able to learn this training. So let me cover a very basic idea of what is dimension and what is measure. This term, you will hear it very, very commonly, very constantly as part of our current training as well as analytic cloud training. Or even when you build dashboards and data analytics using analytic cloud, you will hear this term. So what is the meaning of dimension and what is the meaning of measure? To be able to understand the meaning of dimension and measure in general, I would like to show you quickly here the sample data. So let me create a very simple sample data over here of a sales of a company. So let's say I have a sales order ID, I have the customer ID, I have the product ID, I have the amount, and I have the currency code, or let's say country. So the sales order ID, let's say 1, customer ID is A, product ID is P1, amount is 500 from India. Then we have 2, customer B, product is P2, amount is 800 US. C, customer A again, product is P2, amount is 1500 India. Sales order ID 3 for B, P1 2580 US. 4, customer C, P3 8000, let's say China. So this is my dummy data. This is my test data for the use case understanding. Typical sales data of a company in a sales table. Now, when you look at this data, it is a transactional data. It's a transactional data in general, right? Transactional data. The transactional data always carries facts about your real business. For example, when you do sales in your company, you're recording the sales in your ERP system, and eventually all this data is migrated using ETL tools to BW system. And this is where it represents the transactional data. It is based on real facts. That's why we call transactional data as a facts data. In this transactional data, you have many properties. You see property, this one, sales order ID, customer ID, many properties. But out of all the properties or all the columns, this particular column, what you see here, this guy over here, this particular column, what you see in the system is actually the column which is going to tell you about how good or how bad is this data. So out of the fact data, there is one column, two column, or three columns. Some columns will carry very important information about that data. It will tell the health of the data. If you look at an example, let's say student table. In student table, you have marks. Marks will tell health of a student, whether he's a good student or not a good student, right? So similarly, we have, let's say, HR data. In HR data, you have hirings and termination. How HR department is doing. Are they doing good or are they not doing so good, right? Hiring and termination. So any of these fact datas contain one or two or maybe more than two columns, which basically tells you about the health of the data. Those columns are known as KPIs, key performance indicators, also known as measures. So a measure is nothing but a column or set of column in your data set, in your fact data set, which tells you the health of the data. So if you look at this example data which I have created here, this particular column, which is amount, is the measure column, is a measure column, which will tell you whether how good or bad is this data. That's a measure column, measure column. Yes. So it is measuring the performance of this fact data. A measure is always numeric. Okay. A measure is always numeric. It's a number, but not every number is a measure. Look at the sales order ID. It's a number, but is this a measure? No, it's not a measure, because with the sales order ID, you can't determine anything. Like student, in a student table, there is a roll number. Roll number of a student will not tell you whether student is a good student or not a good student, right? So roll number doesn't decide whether he or she will score very good marks in exam or not. It will be completely based on the real measures. So Measure is always numeric, but not every numeric field is a measure. Yeah, vice versa is not possible. So this is the measure. On a measure, we can apply aggregation. So whenever you have a measure, a typical measure, we apply aggregation on measure. Aggregation like sum, min, max, count, average. These are aggregations. So you can find total of the sales, minimum sales for which customer, maximum sales for which customer, which sales order. Yes, how many orders are there, you can count. What is the average order size? All these are aggregation functions which we can apply on a measure. So this is the concept of measure. So a measure will be a column or maybe multiple column out of a fact data which will help you to identify the health of the system. Okay. Now, next we have the concept of dimension. We have the concept of dimension. So let's understand the dimension concept. So I will go back and I will here. So now in this case of a fact data, the only thing which you can get is an aggregated data about your measure. Yes, that's all you can get from it. Apart from that, it doesn't tell you anything else. On the other side, if I look at, let's say, another data, so I have the customer data, customer ID, customer name. So let's say customer A is SAP, customer B is IBM, and customer C is, let's say, Apple. So this data is nothing but your master data. Yeah? It is your master data. So a master data will be basically a data which never changes or changes very, very rarely in the system. So this is master data. We call it as customer master data in general, right? So master data. Now, what happens is if I combine this master data with the transaction data over there, yeah. So if I combine them, then what happens? I will get a different perspective. So what I'll do is I will go ahead and combine A with this transaction data A. Yes. So I will know that sales 1500 plus 500 for A. So SAP have given me a total sales of 2000. Then I have IBM. IBM, if you see B, so I have B and B, 2580 plus 800. Yes, 2580 plus 800. So what it comes as 3380. That is the sales by IBM. Then I have C, which is Apple. Apple have given me a sales of 8000. So by looking at this data, now you get a different bird's eye view. You get a different perspective. You get a different insight. Yes. So it takes you to a different perspective, different insight. Why? Because you combined it and now you know which company have given you highest sales. So next time when there is a customer event you want to organize, you would definitely invite Apple into that event because Apple has given you the maximum sales in your company. So this type of data is giving you a different perspective. It is taking you in a altogether different dimension. That's why this data is called dimension data. So a master data in the terms of data inside data analytics is called as master data is called as dimension. So now you know what is dimension and what is measure. Yes. So this is the term which is used heavily in our data sphere as well as in analytics cloud, which we all need to be very clear of. Yes. So now like this, we can have other dimension data also. What all the other dimension data could be possible? So we have another dimension data like for example product. So I have product ID and product name. So let's say P1 is laptop, P2 is smartphone, and P3 is let's say DVD drive. Yes. So now if you combine product data with this fact data, your dimension, another dimension, you get all together another dimension. You will get to know which product is sold the most in your company. which are the top selling product categories in your company. Yes, that is another dimension you will get through. On a similar note, I can have another dimension in this data where we have, let's say, a country. Country can be another dimension. CTRY country code, and I can have India, I can have US, yes, I can have the CN China. So now I can look at and I say which is the top business making country for my business. Yeah, that is what I will get to know with the help of the country. So that's another dimension. So these are the different dimensions we can use to combine with the KPIs, with the fact data, and we will get a different perspective every time when we do it with different perspective. On a similar way, we can have time. Time is another very powerful dimension. Like we have day, week, month, quarter, half year, year. Yes, this is another dimension what we have. So when you combine the master data with transaction data, you eventually get a different perspective altogether. And this perspective will help you to build the right insight for your business. Now, the process of combining. So if you look at, we keep the fact data in the center, and then surrounding with that, we have all the master data. So you see, if I combine like this, you see, if I combine like this, combine like this, combine like this, combine like this, yeah, all of this become a very nice, beautiful photo, very nice, beautiful picture of twinkle, twinkle, little star. How I wonder what you are. So it is called as star schema. So in interview, if somebody asks you what is star schema is nothing but when you combine facts along with the dimension to get an insight, to get a better perspective of your data, that is called star schema. In a star schema, we would we would plot our dimensions with respect to the measures. The dimensions is found in master data tables, and fact table contains the KPIs or measures, which will help us to aggregate and get a different perspective. And that is possible by building a star schema. By building a star schema. Now, it may be possible that you can join master data with master data with fact data with master data. You can do many combination. So the kind of combinations you perform, accordingly, it becomes different kind of data model. Yes, different types of data models we can build, and that is why we have multiple variety of data model in the business layer in datasphere. We will also experience that, we will understand with respect to this PPT only. I will show you how different data models are being used in the business layer. Yes, okay, so moving on, let's talk about semantic uses. Let's talk about building a table now. So now we will start with our first practical example of data layer, where we'll start creating a table. So there are multiple ways we can create tables in SAP DataSphere using data builder layer. Data builder layer is the data foundation layer where you build the data. Yes. So now we start with the table. So what is table? Table is a two-dimension structure, as we all know. It contains the data in form of rows and columns. There are multiple ways to create tables in DataSphere. So I will show you all the different techniques to create tables in DataSphere. So first I will show you creating a table by a simple CSV upload. So I'll go to here. You see at the moment my system have nothing. It's a very fresh system which we set up in the previous episode. And now I click on this plus button to upload the data from a CSV file. So I can click on that and it will take me to my computer. It will allow me to choose a file from my computer. I click on that and then I will go to my folder where I've kept my file. So here you see I have data kits. Data kits contains data for the uses for the learning and training purpose. This entire data kit I will be also sharing with all of you as part of study material, so that you can download this data kit and you can start building the use cases, even more complex use cases in coming days as part of our training. So I go inside And today I just use a simple sales order data, yes, of my company to upload it here. So I can click on that. I choose the file, and of course my first column will be a header. Yes, in Excel sheet, if your first column is just the description and the name of the columns, you can keep this checkbox checked. And now you say upload. You can see the upload is happening and the data gets uploaded. So in this situation, what computer does, it will automatically create a table for us. Yes. So it will automatically decide the column names, the table name, everything. It does automatically. So this is the benefit what you get when it comes to uploading the CSV. So generally, when you start for the first time, you start with flat files in your company as well. There are currently, let's say you're going greenfield implementation, and at the moment you are not using any data warehouse solution in your company. At the moment, all the data is maintained in CSVs or Excel files. You can quickly come and upload them. Now, once you come here, this is the data transformation screen. On this screen, basically you can apply some quick transformations on the data. For example, you want to duplicate the data, you want to change some column names, you want to combine some data, you want to apply concatenation. So for example, if I want to concatenate this and this, I can double click, I can click both of them, and I have a smart transformation. I have options to duplicate, delete. Yes, I can apply transformation, and you see there are different options like concatenate, split, extract, replace, change, and filter. So there are multiple options which are possible here. After you upload the data, you can apply simple transformations on the data. If you feel your data needs to be cleansed, you can cleanse your data right away over here. You can also look at data distribution. So if I, for example, choose out of all the sales order, how the distribution of my number of sales order are with respect to sales organization. So I can come here, click this column, go to this tab, and you see out of all the sales orders I have, there are three unique values of the sales organization. Out of total records, there are 313 record for EMEA, 180 record for America, and 7 records for Asia Pacific Japan. Also, you can mark here the key. So you're building a table. So a table will typically contain a primary key, right? So primary key, which uniquely identifies every record. That is what exactly the table is capable of doing, right? So you will have here the classification of data type, what type of data type it is. If let's say the data sphere have selected or chosen any particular data type incorrectly, yes, you can come back and correct that also here. You can force the data sphere to choose or mark one particular column as a dimension. Yes, as a you know as a dimension. Let's say I want data sphere to treat, though it's a number, I want it to treat it like a string. So I can manually come and change that. So you see it has automatically detected the most of the data type. Let's say this one is a date. You see calendar icon. This one is a number. Yeah, this one also detected as a number. This one detected as a date. This one detected as a number. This one detected as a character. You see AA, that's a character. So in case you feel that a particular column and its data type was inappropriately selected or chosen by datasphere, you can always come and modify here. So for now, I will select sales order. You can also see the distribution of sales orders between the ranges. And now you can also check the validation rules. If there are any issues, there are blank data or unsupported data types, unsupported characters, sometimes we get special characters which are not supported by the tools, or there are null values in a key field. You can also detect those issues over here. Now we can click on set as a key. You can do this later also in case you forget to choose a key on the screen. You can do that. On the top you have undo option, redo option, and transpose. So you want to convert a column into a row. You can always do that with the unpivot option also. So now we can click on deploy, and the table will get created with this column as a primary key. The sales order ID of course has to be my primary key. I can click on deploy button. It asks me the business name and technical name. So business name can contain the spaces, because this is basically for the purpose of understanding from the business perspective of a table, whereas technical name cannot contain a space. I can click on deploy button. Yes, I can click on deploy button. It will now deploy my table. So business name is sales space order, but the tech name was sales underscore order. You can see deployment of data successful. So it deployed the table first and then it deployed the data also. So you see the status is deployed. So what is exactly happening when you deploy? So I'll take you back to the previous episode, previous class, where I have explained about how under the hood analytic cloud or a data sphere is working under the hood. So what exactly is going on? So here is the data sphere. So you as a developer have created a table over here, defined a table by uploading a CSV file is using datasphere. So when you do this, you got a table structure defined in a graphical modeling, low code, no code environment. Now you say deploy. When you say deploy, what exactly it does? It will go ahead and run a SQL command behind the scene, because you understand Excel, I understand Excel, but computer only understand, or database only understand SQL. So behind the scene, it creates a SQL that would be something like a DDL command, like create table, table name, yes, sales order, columns, yeah, all that it creates. And this will be created then in the HANA cloud. So as a consultant, you are using a low code, no code environment where you are not writing any much coding. You are just using a graphical modeling option to create a table. So that way, any business consultant who have zero technical knowledge in SQL would be able to do that. That's a great advantage which DataSphere provides us to us. Yes. Apart from that, creating table, there is a lot you can do when it comes to creating a table, which also we will see it now. So once the table is deployed and created, now we have an option to basically go ahead and choose multiple settings for the table. So I can click this object, it opens up for me, and I can start editing this object if I want. Suppose I forgotten to mark the key field, so I can now make it key field. It's possible. When you deploy again, it will fire a alter table command. Alter table command, yeah. So now I have a business name. I have now semantic uses. What is semantic uses? What is the meaning of this semantic uses? So this feature you will see in the views also, and this feature you'll see in the table also. So here it will help anyone. So let's say you build a table, you build hundreds of table, and then you left the company. So when somebody else will come and join your team as a replacement for your work, when they look at this table, how do they know what is the purpose of this table? How do they know? So this is one benefit you get. One is documentation. The second benefit, how do you want the data sphere system to treat this table? Yes, because depending on the type of table, the treatment is different. Yes, let's say there is a patient comes. Yes, there is a heart patient comes. One heart patient who's a heart patient, his blood pressure is very low. One heart patient, which is another heart patient, which whose blood pressure is very high. So both are heart patients, but they need to be treated differently, because the level of blood pressure, level of sugar level in the body, it depends. And the treatment will also change accordingly. The medicines will change differently. So similarly, this patient, this table over here, how do you want your doctor, your data sphere to treat this guy? Yes, that is what the semantic uses type will decide for a particular table in data sphere. So there are different types of semantic uses type when it comes to SAP DataSphere. The first semantic type is called as analytic type. So semantic uses type first is called as analytic, which you saw called analytical, actually that's the name. Then we have relational, then we have dimensions, we have facts, we have hierarchies, we have texts. I guess these are the ones: relational, fact, dimension, text, hierarchy. Yes, and there was one analytical which is deprecated. Okay, so what is analytical? So analytical and fact both are same. These are basically deprecated. So what is the fact data type? What is the analytical data type or fact data type? So data set that indicates one or more measures that can be analyzed. transaction data and contains one or more measure. So now you understand what is a measure. So usually the fact analytical data type will always contain a measure. So think about in our example, the sales order table. That is our fact data type. So next time when you upload a sales order data, that's your fact data type. Next is relational. Relational data set contains columns for basically contains columns with no specific analytic purpose. Let's say org data, organization data in your company. It doesn't contain any column related to analytics. So you will not do any data analytics using that, right? So that is the category of relational data. So it is a data which will allow you to create relation. Now, sometimes you may also have, let's say, connecting table. So there is one table, there is another table A, there is a table B. Now to join this table, there is no direct relationship, but there is a middle table. There is a third table which just contain the relation, relational information for these two tables to connect these two tables together. That's a relational data. So it doesn't give you any analytical purpose, but it contains the relational data. The next one comes is dimension. Dimension you all know, pure master data, data that never change or changes very seldomly. It indicates that our entity contain attributes that are used to analyze and categorize measures defined in another entity. So you have measures defined in another. Look at this example. So we have the data for customer, which is used to categorize the measure defined in another entity. So here you are categorizing SAP this sales, IBM this sales, Apple this sales. So it is categorizing. It is providing a category of the measures available in another entity. Yes, like product master data. Dimension indicate that our entity contain attributes. Yeah, that is clear. That's the only definition we have for dimension. Now, then comes is hierarchies. Very, very important. What is hierarchy? Hierarchies are nothing but it's a kind of master data. It is actually master data, but managed in a tree data structure. Let's say you are creating a employee table. The employee table contain manager ID. So employee manager, it's a hierarchy. It's a relationship between the data. It contains a tree data structure or also known as parent child relationship. So whenever you have a data set, let's say cost center hierarchy, profit center hierarchy, yes, manager employee hierarchy, whenever you have a data set which is related to a parent child relationship or a tree data structure, that's called hierarchy. Why do we build hierarchies? It is after we build hierarchies, when we combine it with the transaction data, it is easy to traverse the data, easy to manage the data, easy to visualize the data. So don't worry, in our training we will also be learning how to build and create hierarchies. Text data. So you all know the concept of text tables in SAP, which contains language specific data, so that we can provide translation of the data to the end users to indicate that our entity contains language column and language specific data, master data. So for example, a product text table contains product descriptions in different languages. So that is the text data category. In the coming classes, when we move on, we will learn about different data categories in our training for DataSphere. Cool. So these are the available semantic uses type available in SAP for tables. Okay, let's come back. Now we have got our table tree data type. So I will change this to a dimension, or I'll change it to fact because this is the sales order data. Yes, sales order data. So I'll change this particular table to a fact data. Very, very important. Next, when we come down, we can see here sales order ID, semantic type. If it has a label, we can choose also the label if you want. Then we can choose semantic type. What is the kind of category this data is? What is the category of this data? We can change the data type. So data type was auto detected by the DataSphere system. If you want to change the data type, you identify from your perspective, from your business need, that a particular column should have been selected another data type. You can always change that. For primary key, you can never provide default value, but for all the non-primary key columns, you can provide a default value. While inserting the data, if the computer does not find the data relevant for that column, or it finds a blank, then it will automatically insert the value which you will give here as a default value. You can mark a column as a not null. Yes, not null means you cannot leave this column value empty. You cannot leave it empty. A primary key is naturally not null and unique. So that constraint naturally applies to the primary key. You can also go ahead and delete columns. You can search columns. Of course, you can see the number of columns available, which are 17. Now you can go to attributes and measures. So that is here. Then we can go to association. Association is basically a loose coupling of one table to another. In the past, we used to create foreign key relationship. It is very similar to that. Then we have business purpose, very important. What is the need of this database table? Why do you create this database table? So by providing this information, later on this particular object can be made available in the catalog. Remember the catalog, do not reinvent the wheel. So when you build something, you want your colleagues to find this object, use this object at later point of time in the business. You don't want them to recreate or redevelop everything from scratch once again. So we can provide a lot of business purpose information which then be visible for the search by your colleagues and your friends and your fellow developers in the company to look forward for your object and not rebuild it. Yeah, not rebuild it. Then comes is table services, where you can specify whether this table will be stored in the memory or whether it will be kept in the cold store. So remember the cold and hot store concept of HANA. So we can decide whether this will be stored in the memory, in the RAM or not. So maybe we can switch it on. Dependent object, very important to indicate a data lineage and data uses. You can find the dependent objects where this table is being used. So let's say if I'm building a big project and I created a table, and then after that it was used by several other colleagues in different objects. So you want to change now this table, and you want to minimize the impact of the change. You don't want the table to be table changes to affect a lot of other participants and causes dump for them. So you can always come back and check the dependent objects. This table depend on which are all the different objects, and then accordingly you can find the impact of change. And then maybe perhaps you can have a meeting with the other colleagues and tell them that I am planning to change my table, kindly be ready to adapt your objects accordingly. So this is like a very use list what you used to do in traditional BW system. So that is about the table settings. Then we are good. If you want to load more data to the table, you have this upload button, which we will also see and use it in couple of minutes. Now I'm happy, I can save the table, but saving table doesn't confirm the changes are deployed to the HANA. They are not confirmed. Table is just saved, the skeleton is saved, but table is not yet active. Yes, table is not yet pushed to the database. So you see, changes to deploy, restore deployed version. So you always have active and inactive version like in traditional BW. So you have changes to deploy, which means you saved some changes. I changed this semantic type, but these changes are not yet deployed. Now, until the changes are not yet deployed, it is possible to roll back the change. So you can roll back your change back to the last stable state. So this is always possible. What you traditionally have in SAP, BW where you have active and inactive version, you can go back to the last active version. I don't want to do that. I want to deploy now. So let's click on deploy. It is deploying. The deployment process is usually deployment and data loading process is asynchronous. You see, we will notify you when the process is complete. So here, this process is basically asynchronous. You don't need to wait here until the entire deployment gets over. Yes. So you can continue to do your work and it is asynchronous. So after a couple of few seconds later on, when the deployment gets completely done, that then it's going to get you a message automatically. Yeah, that is the beauty of datasphere. It is asynchronous. Many processes are asynchronous. So you see, it is now deployed. So my table has been created. So this is how you can create your first table in SAP datasphere with the data. You can click this button to quickly view the data available in the table. So when you come here, you see it is just booting up and loading up on my data. So you can see just is loading, booting up and loading, and in just few seconds, yes, there you go, I've got my data displayed. So congratulations, you just created your first table using data upload approach, where we just upload a CSV file and the table got created. You can also see the table type, its uses, the user ID who created, when was it last deployed, when was it changed. All this basic information, administration information, you will be able to see it right up front over there. Now I would like to next create a table using manual option. But before that, let me hear it for questions from the chat window. So can we write complex formula or case condition here? Unfortunately, no, Venkat. This will be done as part of a view. Yeah, as part of a view, you will be able to do that, but not in the table level while creating the table. Next is there's a question, is there any background job that we can monitor for the deployment process? Yes, later on I will show you whenever these asynchronous processes runs, what was the status of these processes, where can you track them. So there is a beautiful dashboard available where you can check all the processes which are running, which are asynchronous, like deployment of a view, deployment of a table. Where can you check them and what was the overall status at later point of time, you can go back and check. So that is something is there, but it will be discussed in the upcoming classes. Okay, any other questions on creating a simple table? It was simple. Okay. Okay, now let's move on and learn about creating a table from the manual option. Yes, how do we create a table from a manual option? That's what we want to do. So we saw how to create a table using CSV upload. So in this process, you saw how to upload the data. So first step was to upload the data. Then we upload data. Then we saw assigning semantic types, where we choose semantic type like fact, dimension, text, hierarchy, relational, what type of data it is. Then we define primary keys, compound keys, basically combination of primary keys, default value, column visibility, association, field names. You can change field names if you want. Data types you can change, their length and descriptions you can change, and semantics you can add, like what's the label of this column. Then we can delete and upload new data from data files. We can preview and share table with other spaces. So you created this table in my space. It is possible to go back and share this table with the share icon present on the top with other spaces. So you see the share icon. So it's my space, and now I can put the another space name with which I want to share my data. So remember the concept of sharing. Yes, we can do that quite easily with this share button. So we can share the data with other spaces. I'll show you later on maybe. Then we can also allow to refresh metadata for the definition of a remote table. So I'll also show you remote table in coming section. How can we bring in a remote table from a remote data source like BW system? Yes, so that we will see later on. Okay, next I would like to create table using option number 2, which is creating a blank table, which is creating a blank table. So how can we create a blank table in SAP DataSphere? By using the manual option. So the option 2, which is the blank table, is used in cases you will know the skeleton of the data. You will know the skeleton of the table, but you do not know the data yet. So you do not want to sit idle. You would want to create the skeleton of the data first, and at later point of time when the data is made available to you, you would just upload the data in the table. So this is the traditional. Even the BW, you do the same thing. When you go to SC11, you first create the skeleton of the table and then you activate it, and later on you will find technique like ETL or something to upload the data. So we can do the blank table option. So when you come to DataSphere Data Builder, you have the option to create a blank table. So what is my requirement? My requirement today is to, let me talk about our use case. We would like to build an analytic dashboard for our store application. So I am running a very small grocery store, and I am regularly doing the sales in that store. So I have master data like store IDs. I have multiple stores across my country. So I have store information in a store table. Then I do have customer information. I have sales transaction information. Yes, I have employee information and partner information. So all this information I have, and I would like to use SAP DataSphere to build a dashboard and analyze my data using the store. So I would like to build a complete store application. So all this data set again will be provided to you as part of data kit, which I will be sharing with all of you. So if you go to our study material, you will find something called sales ER use case. Yes, so this is our database tables. So one, dimension and sales transaction. Yeah, so these are the four tables. I'm just trying to keep it low with just simple four tables. And of course we can directly upload CSV, but I don't want to do that. I want to show you creating table manually. So let us go ahead and create these dimension and fact tables. Now to be able to make it easy, I have done a bit of design, and I have created the basic skeleton structure as part of a design over here in my presentation. So we will follow this design, and then we will create these tables, and at later point of time we will define a entity relationship between these tables, and we will also upload the data as part of the table. So let us go ahead and create these tables manually. So I'm going to switch over back. I click on new table. We will begin with the first table called sales transaction. So maybe I will dock this particular window on the right, my Excel, my PPT, and I dock my analytic cloud on the left. So it is easy for me to basically see the table structure on the left, and it is easy for me to right away create this table structure on the left side and look it on the right side. So I'm using window left arrow and window right arrow. So now I come back to the business name of the table. It's sales transaction. You can notice the technical name never contain a space. You see there is a star, it is mandatory and never contains a space. So it has put automatically sales underscore transaction as a technical name. So this is a relational data set. I can choose, no problem. And then I can add one by one my columns in the table. So that is what I can do over here. So I add multiple columns. You can see, let me maximize first. It has lost the it has lost the right side part actually. Let me save this table first. The table will automatically get stored in the space. Yeah, let me open that. Okay, cool. So now I've got my table, and let's start building it. So the first column is a key field, which is transaction ID. So Please notice that the column names are case sensitive here. Please make sure that column names ID, I capital, D capital when you are creating, because at later point of time we will have problem while working with this, with these objects. Yeah, while working with these objects, because the data upload will not work. Yeah, data upload will not work if we have issues. Yeah, our data upload will not work. Okay, next what we have is data type. So I choose data type integer 64. If I want to give a column description, the default value I can give that. Then comes is the next one, next column. Let me first give the column names: transaction date, store ID, product ID, sales manager ID, profit, discount, revenue, and cost. Now let's choose the data types. So this one is date. Next one I choose it as string 6. Then next is string 4. Next is string 4 also. Then we have decimal 15 to 15 to. So let's choose decimal 15 to 15 to. Very easy, very graphical, no coding, no SQL is required. And the last one is also decimal. Very nice. So this is our first table, which is sales transaction table. Makes sense. And right now I'm not putting anything else. I'm just going ahead and deploying it. So I deploy and the table gets now deployed. So behind the scene, there is a create table command which is sent to the HANA Cloud in the BTP environment, and the table gets persisted in the database. We have not yet uploaded the data in this table. Let's create the next table. We go back to data builder. As it's a asynchronous process, the system will continue to activate the table for us behind the scene. You see the deployment is successful. The message comes at later point of time. Yeah. So let's create the next table. I will create my next table as a store table, and I will add multiple columns over here one by one. And then I will just say store ID. This will be the key. Next one is store name. Next one is store city. Then I have a state ID, state name, country, latitude, and longitude. Yeah. Now let's mark this dimension. So the moment you mark dimension, see what happens in the column list. The moment I do this, I've got a new column added. Let me explain that. So in a dimension, what happens is, let's say you are building a data insight or data analytics with your data set. Yeah, that's what you are doing in your company. Let me first save it. The resolution is not okay. I store the table. Done. Let me go back. So actually resolution have a problem. Okay. So now you see the moment I change the table type as dimension, what happens? It has got something called label column and semantic type. So basically this new column was added. So for store ID, which is a technical ID like 10,000, 20,000, 30,000, yes, there is a name for the store. So you got to associate, because when you do data analytics, you don't want user to see store ID 10001 1000002. User can't make a sense out of it. So for the store ID, the semantic information is stored in the store name. So we have to change it here in the label column. Okay, I need to refresh. It's not showing up. I will change for the store ID, the store name as a label. So I say, I first mark this one as a text. Yeah, semantic type is a text. Same for the state name as a text, and I will link it. So watch out. In the drop down, now you got a store name and you also got a state name. So for this state ID, state name is my semantic information. It is my label column, which state ID will be, let's say, MH for Maharashtra. Yes. RJ for Rajasthan, DL for Delhi, CN for Chennai, right? So the name will be stored in this. And I'm telling to the computer that this name is my text data, which is represented by the state ID. So that linking you can do in the master data. Only master data type, only dimension data type you can do this. Other data type you cannot. Let's deploy the table, table number 2, and we proceed to create the remaining table also.
So now in this case, we can say text, key and text, right?
Yeah, that's what key and
Whether
text is. This is just
okay.
a way of defining in another way. So you can't do exactly like what BW does. This is just the same way what you do in BW, key text. It's the same thing. But this is the way to define. Let's move on to the next table as per our use case. So I'll create a next table, new table, and let's give the table name as product. Again, it's a dimension. I will have columns. Okay. So I will have a key column as product ID. Next column I have okay. Next is product name, then product category ID, and product category name. And now I will have also the type. So this one is string 4, string 30, string 4, string 30. So once again, we will choose these two as a text data and link it, change the dimension. Okay, it's already there. And then we will mark it product name and product category name. Perfect. Let's deploy the table as a product table. You see, it will be deployed soon and you will be notified. Very nice. In the meanwhile, we can continue our work. It is asynchronous process, as I told you, and we can build our next table, which is the sales manager table. Again, it's a master data, and it's a dimension, and I just have sales manager ID. Maybe I'll add an extra column, and I will have, let's say, location or country. I will default the value for this as US, and of course mark this gentleman as a text and link it with that. Makes sense. So now I can just deploy my sales manager table. Okay, I forgot to mark the primary key. which I do that, system gives me a warning. Okay, let's deploy now my sales manager table. So we just created 4 different tables. 3 are dimension tables and two are fact tables. Makes sense. Makes sense. One table is a relational table or fact table which we created. Makes sense. So now we have our tables ready in the system. What is our next step? Our next step is to basically go ahead and take a break. And then we can come back and create an entity relationship model on top of these tables. So everyone, let's take a break, and then we can come back after the break to begin our next topic, which is entity relationship model. Everyone, let's take a break and we come back after a short break. Okay, everyone, please come back to my screen. So, welcome back after the break. Before the break, we have created the tables in the system. And now what we are going to do is to create an entity relationship diagram. So what is entity relationship diagram, guys? And why do we need it? Now, before I create entity relationship diagram, I also want to talk about the time data. What is time data and why do we use time data in SAP DataSphere? What is the importance of time data when it comes to SAP DataSphere? So time data will help you to enrich our model and stories with the time dimension. So you know that we have the time dimension. Time is very powerful dimension in SAP DataSphere, or in fact in any data analytics or data insight products. Time plays a very critical role. So time is a dimension which represents day, week, month, quarter, half year, right? So that is what time it represents. It's a dimension which represents this data. We can enrich our models, which we will build in coming days, like views and everything, with and stories with time dimension. By default, time is treated by system as a hierarchy because there is a clearly defined hierarchy for this. We can create time dimension data at space level. The system will automatically create the time tables known as M star tables. So what system will do behind the scene, it will automatically create many database tables and it will store the year and time data. We can decide which how many years of data we want to generate using time dimension. The granularity of the time dimension will also allow us to achieve the drill down. A timetable is only created once per space. You cannot create multiple timetables. Okay, only once you can create timetable per space. So a timetable or tables, I would say, are created once per space. So in one space, you cannot have multiple month, day, quarter table. Yes, only once per space you can create timetable in SAP DataSphere. Okay, let us go ahead and see how to generate timetable before we start building further models. So I'm going to switch over back. You can right now come to the data builder layer and you can see we don't have any timetables here. We just have sales order, sales transaction, store, product and sales manager. Now I can just go back to my space management and I'll go to the time data over there in the space management section. And here I'll say create tables and dimensions. So we click on that and you see time tables. You see M underscore. You see M underscore. So this is the time dimension table. M underscore. You see M underscore. So all the tables starts with M underscore. Okay, M underscore. You can choose the year, from which year to which year you want to generate the data, as I mentioned. You can choose the semantic name of the table: year, quarter, month, yes, day. You can see these are different tables which we have. So system will also generate translation table for the time. Yes, that's what system will do. Okay, let's click on create button. It will generate the time dimension data automatically for me. That's what the system will do. So you can see now it is generating the data. It will take few seconds. Yes, we can later increase, decrease the time range. Yes, there's a question Venkat is asking. Yes, so you can come back to edit and we can change the range if you want. Okay, it will just regenerate the data, not regenerate tables. Okay, so it will never have a bad impact on your system. Okay, so it's generated, and now if you go to data builder, what you see miraculously, you will actually see the timetables. Wow, look at that. Awesome, Anubhav. Look at this. They are generated. You see M star table. All are M underscore, M underscore. It also create views. Yes, on top of the time data like month, quarter, and year. That it does. That's okay. Now, let us move on to the next part. Next, we will create an entity relationship model. What is the entity relationship model and why do we use that? So, an entity relationship model provides variety of benefits. What are the benefits it provides? So, first thing it provides is definition of entity and their associations or their relationships with other entities. From business standpoint, so basically it's more about functionality, functional. Like sales order table, store ID connects to the store ID or the ID of the store table. Yes, that is the entity relationship. It tells how the objects, your models are related with each other. It design physical or remote models. It reuse existing tables or views, basically existing objects from data builder. So you can reuse existing objects. We can add new entities on fly. So we created a table manually and with the CSV. You can create tables on the fly with the entity relationship model itself. Also, we get in editor real-time data preview. So we can slice and dice the data right away after creating this. We can also do model import and export. So suppose your friend have created a particular entity relationship model in dev system or in a test environment, and now you want to reuse that. So in that case, you can use the entity relationship model and you can do import and export. So basically entity relationship model is a not just a view, but we would like to consume this entire entity relationship model in analytic cloud. You can do that. It represents the relationship between the tables and views and help us to define the relationship once and reuse that relationship again and again. So you don't need to define the relationship again and again. Yes. So that is the benefit of entity relationship model. Let us go ahead and talk about it and create it. So we can switch over back. And when you scroll to the right side, you see entity relationship model. We define a new entity. So we click on that. And now we can see the list of tables. You can click this cancel button to remove the panel, side panel, to get an extra bit of space. And now we can drag and drop everything over here to create our entity relationship. So I'm giving you the design in the presentation. You can follow along. This is our design to create entity relationship. Yeah. So we have the sales transaction table. So let me drag and drop that. Then I will have the time dimension table for the day. I will drag and drop that as well. Yes. The next one, I have the product store and sales manager. Yeah, that's the data. So product. So you can drag and drop in any order, doesn't matter. Store and sales manager. Yes, that's the data. I will just put it here. 1, 2, 3, and 4. And now what I'll do is I will just start doing the connections. So we can start doing the connections between them. So you click the sales transaction, you see this arrow icon. So there are multiple options. You can add a new column automatically here directly, and that will be eventually added in the table. You can basically create a view from this exact table. You can also create a table itself. Yes, so you don't have to create a table. This is third technique to create a table. You don't have to do that with CSV or new table option there. You can do it from here. You can create relationship association between one table and another. You can preview the data right away. You can also see the impact and lineage analysis. Let's say if you delete a table, what is the impact of that with other entities? Then you can also edit the CSN annotation where you can provide extra functional information about the table. And then you can also open this table in a new tab. All of that you can do with the help of entity relationship model. So let us go ahead and now connect this guy to this table, and system automatically identify the relationship. You can also see if there are any issues. We will get to know them over here. You see association with, you see this issue, must define the column mapping. So computer is not able to automatically detect which column to be mapped with the day table. That computer is not able to automatically identify. So no problem. We can do that by going to details, and in the detail you can expand and you can now see the columns of both the tables. So which column will connect to which column, that you can easily see here. So of course my transaction date to be connected to the identifier. That is the correct relationship. So the issue will go away now. So you see that one issue which was coming, it is gone. So that is how we can define the relationship between the columns. You can also do it here, or you can expand and do. There are no errors now. Similarly, let's drag to the product. Yes. Let's see if it is identified. Yes, see, automatically it is connected product ID with product ID. How? Based on names. Then let's define next with the store. This will also get automatically connected store ID with store ID. Let us define next. Sales manager. You see, sales manager connected to sales manager. Perfect. Fantastic. So that is your entity relationship model. What we got over here. You can change the arrow to left side a bit here to make it look better. Yeah. Now I can deploy this entity relationship model. Let's name it as ER model store. And you know what you can also do, if you, let's say, don't want to do this manually. Let's say sometime you have hundreds of tables and somebody have already done this work for you in the past. You can simply import export. So I can now export, if I want, this model to a JSON or CSN file, and then later on I can import directly. So in case this exercise which I showed you, you don't want to do it manually, what I will do is I will give you in study material this sales ER model JSON file. So you simply go and open create entity model, come here and say import and can browse, and then you can browse this JSON file. JSON stands for JavaScript Object Notation. So it's a special data format. So that you can double click, it will import and it will create the same thing what you see on my screen. So that is how you can create an entity relationship model without any problem. So can we define the join condition or is it default full outer join? I think you can define the join condition. So you can come here to details and you can specify the join type. But I think that will not be done here. It is just going to specify which column connects to which column. But the join type, whether it is inner, outer, left outer, full outer, everything will be done in when you create a view on top of it. Okay. When you create a view on top of it, so that time it will help you to at least find out the relationship very quickly. But the join type you will specify in the view during the view creation. That is where we can do it. So that is how we can create a entity relationship model in the analytic cloud. You can also upload the entity relationship model from a JSON file. So that's an exercise for all of you. You can upload the JSON file provided in DataKit to create your ER model. That also you can do. Okay. Now let's talk about views in DataSphere. Very important topic. What is a view and why do we use a view? A view in DataSphere provides several benefits. Why we create views in softwares actually? What is the main benefit? So first of all, the views are graphical or script based. You can decide which type of view you want to create, graphical or script. You have a flexibility to create a script based view as well. We can define view on top of remote replicated data source or tables. So you already created tables, but we can also have remote data source where the data will come live from underlying BW system. You don't have to create a table at all in the data sphere. It can come from remote or it can come from replicated, means a table which is fully replicated from BW system to SAP data sphere. We can get the object. So that also we can do. So this is what we can do with the help of view. Any kind of data source, whether it is a replicated or whether it is a created data source like a table which we created in the our current class, we can get the view. We can get the view created. We can define joins, unions, rename and remove columns. So of course the columns when you remove, you are just absconding that column from the display. So view is a virtual table, right? It is not the real table. So let's say there are three tables you use. Each table have 10 column, total 30 column. You don't want all 30 column for reporting. You want only 5 column. Yes, you can just remove the columns from the output of the view. You can define the join types. My friend was asking, Anubhav, can I define the type of join? So that you do it at the view level. Yes. Next, we can add calculations and filters. The best part of what I love, you can enrich your data with geo coordinates and apply currency conversions. We can create dimension, fact, or relational data models using view. We can create parent child or level based hierarchies in dimension views. We can define measures and attributes in fact views. And with the graphical view builder, you can also compute and display SQL statements. So of course, when you use graphical view, what is the SQL generating behind the scenes? You can always see that. Yes. So SAP Data Sphere will allow you to leverage local table, remote table, replicated table, views, existing views, combine everything together to build your data model. A view can also, of course, can contain additional calculated dimensions and measures, which you will see it in a minute. What can you do? Where do you create the view? What is that which we do? Where do we create the view? So we create the view using view editor. So we have a view editor. So what is the view editor is capable of doing? We can define a view on top of remote, replicated, or local tables. We can define measure and attributes for fact data. We can create multi-language text fields. Define join types, joins, associations, aggregations, unions, etc. We can rename columns for reporting purpose. Suppose in your table, the sales order number is named as VBELN. But when you report that column, when you display reporting of the data, perhaps it will not help you. Yes, you want to show the column name as sales order ID. That's more meaningful for the reporter who will report this data from the view. So in that case, it is an advantage that we can rename the columns on the fly. It's a virtual table. The data will never be persisted permanently, but it's a virtual table. We can add filters to discard unnecessary data, hence improve reporting performance. We can project columns and also reduce volume of data transfer. Then next we can apply access control, create input parameters which can filter further the data. We can also decide view persistency. We can also view data at each node. At each node you can also see the data. So these are the benefits of creating the view. Let's go ahead and create two views, two graphical view. One first I'll create a simple view with the one table which we created earlier. So we can come here and we say new graphical view. I will go to the view editor and I will use my first table which I created in today's class from Excel file, sales order table. Yeah, this was the one I created. I drag and drop and you see sales order table. I can now double click or go to detail and I can see here on the right side my view settings. So this is my view name. So let's say view PW sales order. This is a good naming convention to choose. Now that's my business name. So let's say view sales orders. And this is my technical name, VW sales orders. I can change. Now I can choose the data type as fact, which is very important. Analytical data set is deprecated. It will be removed soon from the system. We choose fact. We expose for consumption, which means this view will be made available later point of time for any business layer to consume this view and build on top of this some models. Then we can come down. We can also choose here the measures. So right now you see there's an error coming. If you click here the error, it says this is a fact type and it must have at least one measure. Remember the concept of measure and KPI? Yes. So we can come down, and of course we have multiple measures to choose from. So I will choose gross amount, net amount, and tax amount as my measures. So I can manually drag and drop them on the measure section. So let's drag and drop like this. You can also go down and you see more option, and here also you can mark it as a measure if you want. So you see, change to measure. For a numeric column only it will be allowed. So we've got our measures, and now see the error is gone. The view is ready. The view type is a fact view. Fantastic. Let us go ahead and now deploy the view. The view will be named as business name and then the technical name, and click on save. Congratulations, your first view is ready. Right now it's not very complicated. It's just with a one single table. But of course we will increase the complexity soon. We will learn how to create more complex views. Now, if you come back to this note, you can preview the data by clicking this data viewer button to see the output of your view. Now, just a small note here to notice. Sometimes this data viewer doesn't work, or it is very slow. So you got to be patient here to view the data. Yeah. So you see, this is the data of the view. You can export debug CSN. So you see, this is a JSON it has created. You can also view the SQL code which was generated behind the scene. You see, this was the SQL code, the select query which was generated behind the scene with this view. You can copy that. If there are errors, you will also get to know them over here. Fantastic. So this is how we can create a very simple view. Can we see SQL generated log? Yes, I think we can also see the generated log behind the scene, what it did. Yes. So somewhere we should see preview SQL. So here we can see the SQL. It is not showing the one which was generated behind the scene. Ideally, it should show in activation log. Maybe I will show you. I'll find and show you later. Yeah. Okay. So that was a very simple view. Now the next thing which we want to do is we want to create a more complicated views. So let me create a dimension view to basically show my store data. Yeah. So let's come back and create a new graphical view, and I'll go to table. I'll just drag and drop my store. And what I want to also do, for reporting purpose, I need to build a map. So later on when I go to Analytics Cloud, I will show you creating a map, geo map. On the geo map, I would like to show the coordinates. Where are my stores on the map later on? Yeah, I will do that later on. So at that time, I would need a special column. The name of that column or the type of that column is called ST point. It's basically geostationary coordinates. Now, at the moment, we have put latitude and longitude column in the table for store, but we don't have information about a geolocation column. However, the geolocation column will be constructed with the help of latitude and longitude present in the table. So what I can do is, for the first time, I will add a function. I click on function, and here I will add a new column at runtime. So I go to details. This is a new calculated column I'm adding. Yes. And we can rename to, let's say, location, to this column as location. So I'm going to come back here and I'll say it's a location column I want to create. And we have the plus button. And you see right now there is no option available to add a coordinate. Why? Because the type of the view is automatically categorized as a relational data set. So we change it to dimension data set. Let's call it as view store. Yeah, store dimension view. Let's name it as VW store. Enter dimension. Now you come back to the function. You will see an option to create geo coordinate column. Fantastic. This was not there earlier. Somebody asked me, Anubhav, can I create a complex calculation? Yes, you can. You see, we have option to create calculated column. Maybe in the coming episodes, I will also show you that later on. We can apply currency conversion on the data. Now I choose geo coordinate, and then you see it has automatically detected my latitude and longitude columns from my table. Automatically it has detected because the names were correct. Yeah. So if the names are latitude, longitude, it auto detects. If not, then you have to choose from the drop down which column are latitude, which are longitude. So this is the name of the new column which it is creating at runtime. You can clearly notice the data type, and you see this icon, it's a map icon, map pinpoint icon, which is indicating the data type of this guy. Makes sense. Makes sense. Now I can just deploy and test my view. So don't forget to deploy. So let's deploy the store view, which is a dimension view. So now you see it is deploying. We can also switch on for consumption. That is a very important property. Let's redeploy. So this process will again run asynchronously and let it get completed. In the meanwhile, I'll create one more graphical view for my transactions data. So I'll come back. I'll drag and drop sales transaction table over here. You can see it has come. Now the next thing which I will do is I will mark this view as view sales transaction view, VW transactions, and I will choose it as a fact. Expose for consumption, add my measure, profit, discount, revenue and cost. All are my measures. Drag and drop. Yes, I create as a fact. Now I will start association. I will start adding relationship of this particular view with other view, or maybe let it be a fact view. On top of it we can create another view, and that view we can add the relationship, or we can do the relationship here itself. So you come down at the bottom and you see this association. Yes, association. Click on plus button and choose association. So there are many ways of doing same thing. And now in this association we will choose our other other tables and views. So we choose the product view, sorry, product table, and click OK. And now you see the remember the entity relationship model which we had. It is basically picking that information from that entity relationship model. Wow. And it has added a association. Yes, added a association. This is very, very powerful. So now once the association is added, we can just go back to the view and add the next association. So you can see this is the mapping which has been carried out automatically by this system. So next I will just go back, sales view. Again I add one more association, and this association I will add with my sales manager, and maybe I will also add it with my view store. Do I see my store view? Here it is, store dimension view. Let's choose that, click OK. So you can notice I can add one view with association to another view. So you see now I've added the store dimension view which I've created as an association to this transaction view. Yes, I can click this button, I can switch over back to the view. Let's add the last association, sorry, second last. We will add the sales manager. So whatever we did in entity relationship, we are reusing that over here to create association. I will explain what is association. Let's switch over back and let's also add the day, our time dimension data day. So I will use the view rather than the table for day dimension. And here it is giving me an error. So let's connect transaction date with the date, the relationship. Okay. So we've added multiple association. I will show you the use of this association later on. Now let me explain why we are not calling it as a join, why we are calling it as an association. So what is the concept of association? Let's quickly talk about that. So an association is a relationship between entity and other entities or views. So basically it's a relationship, what you typically know as foreign key relationship, right? So that's what it represents, a relationship. But it is very different from a join. Why? A join, when added, is bound to perform. So when you apply a join will always be performed. It is bound to perform. Yes, it is always bound to perform. There is no way we can avoid database to not carry out join. Since database has to mandatorily do the join, it takes time. It takes time to perform the join and bring your data. Whereas association is a loose coupling. When we read data from the view, the data will be fetched from main table. And when we use association, only then the join will be carried out. At runtime, so you are loading data lazily. It's a lazy loading of data. I'll take an example. Suppose you are creating a use case where you are associating your sales data with customer data. So you have sales and you have customer. So if this line is a join, what happens at runtime? The moment you say get me the sales data, what system does? It will by default do the join. It will always do the join, and it will also fetch you customer data. The customer data is readily available always, all the time. So database has to do lot of work to get corresponding customer information for each sales order. Yes, which will take a lot of time. It's time taking. Whereas if you do this as an association between sales and customer, on the first run, when you run the view, system will show you all the sales orders, only sales orders. It will never ever ever fetch the customer data. Yes, never. When you say drill down in the reporting, in reporting you say I have sales data, please show me customer for this customer data for this particular sales. At that time when it does drill down, then it will fetch the customer data on fly. And you know what? The best part, it will not fetch all customers data present in customer table. It will only fetch you the data for the sales order on which you did drill down. So say, let's say sales order 1002. It has a customer C2. So it will only fetch the one record for C2, customer C2 data. This is a great performance improvement in terms of when you do reporting using our data set. That is why we prefer to choose associations over the joins, over the joins. So you will see the power of this when I do reporting at later point of time. Yes, at later point of time when I do the reporting, that time you will see the power of it. Maybe today you just understand the concept, but when we go in detail, that time you'll understand the power of it. Now, before I wrap today's class, we will close here. We'll not do further data builder, but I want to do a connection of our analytics cloud account and datasphere account. So last class we set up the analytics cloud account. So we already set up our analytics cloud account along with the SAP datasphere account. So both the accounts are already created. So we would like to go ahead and connect today our SAP analytics cloud account, which was created as guided experience, and we would like to basically connect it with our own datasphere tenant. Yeah, that is what we want to achieve. So I will switch over to my SAP Analytics Cloud account, which I've created as a user experience account in the previous episode. And I want to connect my SAP Analytics Cloud account with my DataSphere account. So the very first thing you need to understand, what is the name of your DataSphere account and what is the space name. So this is the user ID and this is the space ID. Both are coming here. You can also go back to the space management and check the same. Yeah, you can go back and check the same. Okay, you can come back and check the same. So you can see this is my space ID. It never changes. You see, it is it is grayed out now. You can't change it. So what you do is now you will use this space ID or the user ID. So in fact, you should use user ID, yeah, which is in this case is same. So we take the user ID, we copy that, and we go back to SAP Analytics Cloud account. And here we go to this option called connections. And here we will create a live data connection with SAP DataSphere. So we click on plus button. We choose connect to a live data, SAP DataSphere, and here we will give the name. Now remember, if you use the SAP experience option to create your DataSphere and your analytic cloud account together, you must choose the name here, same name as the username of your DataSphere account, because this name will be used to do single sign-on. We put a description, Anubhav DataSphere live connection, anubhavtrainings.com, and now we put the host. So we switch over back to DataSphere. We copy just the host name, bring it back over here, remove the slash, remove the HTTPS, put the port number 443. That's a default. That's a default. And you see it is showing single sign-on. Let it be. So what it does, it will basically take this name and it will search the SAP experience accounts in this particular data center. US10 is the data center it has given me. So in that, it will search for this user and it will automatically do a single sign-on, provided that in another tab you have already signed on. This is mandatory. In the another tab, you must already sign on with your user ID, the same user ID in another tab of same browser. Yeah, yeah. I would request you to use Chrome browser. Yeah, it will take the cookie. It will take single sign on. It will connect. Click OK. You see, it is now trying to connect. And voila! Congratulations! Congratulations, everybody! You see, a live data connection is created between Analytics Cloud and SAP DataSphere. Fantastic. Fantastic. Awesome. So this is how we can connect Analytics Cloud account created with guided experience with SAP DataSphere account with a live data connection. And soon in the upcoming episodes, I will teach you how to use one of the analytical model or data business layer models in SAP Analytic Cloud to build dashboards and reports. Makes sense. Makes sense. This is how we do the connectivity. Very, very important. So please follow that and kindly do the connectivity so that it will be smooth experience for us to build the dashboards. With that, thank you so much once again for joining today's episode. I'll catch you up in the next class next weekend. Have a nice day. Goodbye. Time for your questions if you have.
Yeah, hi, bro.
Yes.
So can you go to DataSphere actually? Can you go to DataSphere
Yeah,
screen?
I'm in
So
DataSphere.
till now, yeah, till now you showed me only a graphical view, right? Not the new skill view or anything.
We are yet to come, sir. There are many things. We just started our
No, no, no.
course.
This, yeah, this we learn only in the new graphical view and the entity model. These two only,
Yes,
right?
yes, yes, sir.
Yeah. So here my question is actually, so you created new entity relational model, right? So why again you created view actually? So can we not create the data presentation on entity model?
Very good question. So entity relationship model is not a view. It is just the metadata information about
Okay.
your relationships.
Mhm.
Yeah. Let's say
Yeah.
one boy met a girl. Now they've done a commitment that I am your boyfriend, you are my girlfriend. Yes. But they are not yet married.
Okay.
It's just a soft commitment. It just identifies that you are in a relationship. Yes. Now you take this relationship to the next level, which is marriage. So that's
Okay.
what is
So view
happening.
is a yeah.
Yes.
So view is a mandatory to present data in the analytical
Yes.
source.
So entity relationship is just merely a status. I am i am
Right.
right now in relationship with somebody. I'm not open for any other relation. That is what it indicates. Yes.
Got
Whereas
it.
a view is actually concrete relationship which you can use to fetch the data. So if you hit something query on this, you can't hit a query on this, but you can hit a query on this.
Mhm. Yeah. So in this case also, so we can hide the ignore the some of the scenarios. So we make it directly on view, right? So
Yes, yes, we can.
just joining, yeah. Okay. Without entity
So
model.
without ER model, you can create a view also.
Yeah.
It is possible,
View.
possible.
Yeah.
But
It's got it. Right.
my job as a trainer is to show you the best
Yeah.
practice,
Yeah.
the gold standard,
Yeah.
the right way of doing
Right. Right.
things. Mhm.
I just I'm asking a
Yes,
little,
yes.
thinking little
Very
ways,
valid question.
more
Very
ways.
valid question. I love your question. Perfect.
Yeah.
All right. Thank you so much. See you in the next class. Goodbye.